Okay, let's take a look at 9C on page 149. Without using technology, sketch the graph of each function, label all intercepts. Okay, y equals x cubed minus 4x squared plus x plus 6. So, for p of x, the possible integral zeros of the polynomial are factors of the constant term, which is positive 6. So these will be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So we'll test these values to find a first factor, and we will find p of negative 1 is equal to 0. So we'll use synthetic division to find the other factors. We are subtracting, and the coefficients are 1, negative 4, 1, and 6. Okay, bringing down the 1. 1 times 1 is 1. Negative 4 minus 1 is negative 5. Negative 5 times 1 is negative 5. 1 minus a negative 5 is 6. 6 times 1 is 6, and 6 minus 6 is 0. So the remaining factor is x squared minus 5x plus 6 can be factored to be x minus 2 by x minus 3. So the remaining factors plus the x plus 1, so y equals x plus 1, x minus 2, x minus 3. So we'll use a table again to organize the information about the function and to sketch the graph. So the degree is 3. The leading coefficient was 1. The end behavior, it extends down into quadrant 3 and up into quadrant 1. The zeros are negative 1, 2, and 3. The y-intercept is 6. And the intervals where the function is positive or negative. So the positive values of f of x exist when x is between negative 1 and 2, and when x is greater than 3. And you could do test cases to test this out. The negative values of f of x are in the intervals when x is less than negative 1 and x is between 2 and 3. So if we take a look at our graph, the intercepts, the zeros are listed, and the y-intercept is listed. Our scales on our x and y axes are consistent, they're correct, and we can see a curve in this cubic function, curves with relative maximum and minimums And the positive and negative values are definitely in sync with our table.